ಸೊ ಹಾಯ್ ಹಲೋ ನಮಸ್ಕಾರ. ಎಲ್ಲರೂ ಹೆಂಗಿದ್ದೀರಾ? ನಾನಂತೂ ಸಖತ್ತಾಗಿದ್ದೀನಿ. ನೀವು ಚೆನ್ನಾಗಿದ್ದೀರಾ ಅಂತ ಭಾವಿಸ್ತಾ ಇವತ್ತು ನನ್ನ ಇಂಟ್ರೋ ಕೊಟ್ಬಿಡ್ತೀನಿ. ನನ್ನ ಹೆಸರು ಭಾರ್ಗವ ಅಂತ. ತಿನ್ನೋದು ಮಲಗೋದು ನನ್ನ ಕೆಲಸ. ಬ್ರೋ 24 ಗಂಟೆಯಿಂದ ಇದೇನು ಮಾಡ್ತೀರಾ? ಟೈಮ್ ಪಾಸ್ಗೆ ಏನು ಮಾಡ್ತೀರಾ? ಅದಕ್ಕೆ ತಾನು ಇಂಜಿನಿಯರಿಂಗ್ ತೊಗೊಂಡಿರೋದು. ಗ್ರೇಟ್ ಐಡಿಯಾ ಅಲ್ವಾ? ಇಂಥ ಐಡಿಯಾ ನಮಗೆ ಮಾತ್ರ ಬರೋದು. ಸೊ ಇವತ್ತು ನಾನು ಓ ಎಸ್ ಬಗ್ಗೆ ಸ್ವಲ್ಪ ಕಾನ್ಸೆಪ್ಟ್ಸ್ ಹೇಳ್ಕೊಡ್ತೀನಿ. ವಿತೌಟ್ ವೇಸ್ಟಿಂಗ್ ಟೈಮ್ ಜಂಪ್ ಆಗೋಣ. ಸೊ ಇದೇ ನಮ್ಮ ಸ್ಲೈಡ್ಸ್. ಸೊ ಇಲ್ಲಿಂದ ಸ್ವಲ್ಪ ಇಂಗ್ಲೀಷ್ ಮಾತಾಡ್ತೀನಿ, ತಡ್ಕೊಳ್ಳಿ. So today's topic is operating system for IoT devices. IoT in the sense Internet of Things. So contents covered under these presentations are introduction to operating system, examples of operating system, IoT operating system, parameters for IoT operating system, why we need of OS for our operating system, some IoT operating system in use. Operating system. Generally, what is the meaning of operating system? Operating system is an interface between a user and the computer system. The operating system helps interact with an application with the hardware part without knowing about the actual hardware configuration. The operating system helps in improving the computer software as well as a hardware. Without OS, it becomes very difficult for any application to be user-friendly. Operating system provides a user with an interface that makes any application attractive and user-friendly. Examples of operating systems: Windows, Linux, Mac OS, Android, and iOS. These are some important operating systems or important examples of operating systems. IoT operating systems. The use of operating system for IoT hardware is often categorized into two groups: end devices and gateways. End devices or nodes are often IoT smaller in capability as compared to gateways. While IoT OS are an evolution of embedded system or embedded OS, IoT brings its own additional set of constraints that need to be addressed. A mix of open source and closed source IoT OS exists in the market. Since IoT is varied in terms of applications, hardware, and connectivity, we expect the market will sustain multiple OS rather than just a couple of them. Parameters for selecting a suitable IoT OS. Footprint. Since devices are constrained, we expect OS to have low memory, power, and processing requirements. The overhead due to the OS should be minimal. Scalability. OS must be scalable for any type of devices. This means developers and integrators need to be familiar with only one OS for both nodes and gateways. Portability. OS isolates application from the specifics of the hardware. Usually, OS is ported to different hardware platforms and interfaces to the board support package in a standard way, such as POSIX call. Modularity. OS as a kernel core that's a mandatory. All other functionality can be included as add-ons if so required by the application. Connectivity. OS support different connectivities protocols such as Ethernet, Wi-Fi, and etc. Security. OS has add-ons that bring security to the devices by way of source, boot, SSL support components, and drivers for encryption. Reliability. So this is essential for mission critical systems. Often devices are at remote locations and have to work for years without failure. Reliability also implies OS should fulfill certifications for certain applications. Why use a separate OS for Internet of Things devices or IoT devices? The physical size of IoT devices is becoming increasingly smaller. Some are even required to be wearable. These physical parameters put significant constraints on the hardware and hence the software. An IoT OS is considered successful when it can be embedded within an internet connected device, run software and process and store data on the host IoT device without breaking too much of a sweat. Best IoT systems in use. Mbed OS is a free open source operating system widely recognized for its usage of an ARM processor and for offering a wide array of connectivity options that developers can play around with, including Wi-Fi and Bluetooth. One benefit that developers enjoy with the Mbed OS is that it keeps their code clean and portable, as well as the ability to make a portable of IoT applications with the use of ARM context M based devices. MicroPython is a very compact open source re-implementation of the Python programming language with a focus of microcontrollers. An advantage of MicroPython is that it allows developers to rapidly evolve from learning the basics to implementing real project code. Embedded Linux is built for embedded devices and it uses a slightly modified version of the Linux kernel. The smaller size and power of embedded Linux facilities that the integration of all requirements of IoT devices. So we will find that it's useful for navigational devices, tablets, wireless routers, and many more. This is another free open source operating system that enjoys the support of a large community and many resources that contribute to the development of Tiny OS, which is dialect of the C programming language. This operating system enjoys large support among the development community because of how it optimizes the memory of IoT devices and how the OS tends not to overload IoT devices. One key advantage is transferability. Windows 10. Windows 10 IoT is simply a component of the Microsoft Windows 10 operating system, but it is designed with IoT devices in mind. It is divided into two parts. One is Windows 10 IoT Core, which is designed to support small embedded system devices, and the other is Windows 10 IoT Enterprise, designed to support heavy duty industrial application with high grade reliability in mind. Thank you guys.